Hello friends, and welcome to Webronaq. Here is a question worth sitting with. When your browser loads a page, how do the two machines involved even agree on how to talk to each other? The answer is a protocol. And right now in 2026, a very visible protocol battle is playing out across the web. HTTP version 2 still carries about 51% of page loads worldwide, while HTTP version 3 handles roughly 21%, according to Q1 2026 traffic data. Those two versions use completely different transport strategies, and the gap between them reveals exactly why protocol choice matters. In this video, we will walk through what protocols are, how they are organized, the main types you will encounter, and why the HTTP 2 versus HTTP 3 story is the perfect live example to tie it all together. Alright, so what exactly is a protocol? Think of it like a shared rulebook. Two devices that want to exchange data need to agree on three things before a single byte moves: the format of each message, the order in which messages are sent, and what to do when something goes wrong. A protocol is that agreement, written down and followed by every device that wants to join the conversation. Without it, a laptop and a server might both send data, but neither would understand the other, the same way two people speaking different languages talk past each other. Protocols make reliable communication possible across billions of devices, built by thousands of manufacturers, running completely different software. Now, protocols come in many flavors and handle very different jobs, and that is where layering comes in. Now look at this. Sending data across a network involves a chain of jobs: turning data into bits, routing packets through the internet, ensuring delivery, and finally, making sense of the content at the app level. No single protocol does all of that. Instead, protocols are organized into layers, where each layer handles one specific job and hands its result to the layer above or below it. The most widely taught model is the OSI model, which defines 7 layers. In practice, the internet runs on the TCP/IP model, which collapses those into 4 layers: application, transport, internet, and network access. What is powerful about this design is that you can swap a protocol at one layer without touching the others. HTTP lives at the application layer, TCP and UDP live at the transport layer, IP handles the internet layer. Each one is a specialist. Let us meet the key types next. Here is the interesting part. Protocols cluster into 4 main categories, each doing a distinct job. First, communication protocols like TCP and UDP operate at the transport layer. They decide whether delivery is guaranteed or fast. Second, application protocols like HTTP, FTP, and SMTP sit at the top layer and define what content is requested and how it is structured. Third, the network protocol, IP, handles routing. Every packet on the internet carries an IP address, so routers know where to send it. Fourth, security protocols like TLS sit underneath HTTPS and encrypt everything in transit. In 2026, data from technologychecker.io confirms that roughly 94.5% of all global web requests already travel over encrypted HTTPS connections, meaning TLS is now essentially universal. These 4 categories are not independent silos. They stack and cooperate, and the next slide shows exactly how. Let me show you how this all comes together. HTTP/2 stacks 3 separate protocols: HTTP/2 at the application layer, then TLS for encryption, then TCP for transport. TCP is connection-oriented, meaning it guarantees every packet arrives in order. That reliability is great, but it creates a problem called head-of-line blocking. If one packet is lost, every stream on that connection freezes and waits for it, even streams that have nothing to do with the missing data. HTTP/3 takes a different approach. It replaces TCP with QUIC, a protocol built on UDP. QUIC bakes TLS encryption directly in and gives each request stream full independence. Lose a packet in one stream, and the others keep moving. On mobile networks with typical packet loss, benchmarks show HTTP 3 can be 30 to 50% faster than older protocols. HTTP/2 still leads page loads at 51%, and all major browsers fall back to it automatically when needed. Alright, let us bring it all together. Protocols are the agreed-upon rules that let any two devices communicate reliably. They are organized into layers, with each layer handling one specific job. The 4 categories to remember are communication protocols like TCP and UDP, which decide how data travels; application protocols like HTTP, FTP, and SMTP, which define what is being requested; the network protocol IP, which routes packets to the right destination; and security protocols like TLS, which keep the conversation private. The HTTP/2 versus HTTP/3 story we followed through this video is a perfect example of all 4 categories interacting at once, playing out in real production traffic right now. Once you understand what layer a protocol lives on and what job it does, any networked system becomes far less mysterious. Thanks for watching, and I will see you in the next one.